Now let's have a go. And you remember I said to you before, sometimes it even doesn't look like it's going to make much of a difference. It helps to let your integral equal something. Just makes it a little easier, simpler to manipulate. So I'm going to call it capital I. You don't have to. It will just make it a little more straightforward. Okay. Integration by parts for this question. What's the first thing we have to do? I have to split it in some way. I have to select, right? So what did you pick as u? Now you can choose either, can't you? Does it matter? Sometimes, you remember, I showed you an example where it sort of blew up, right? Where you chose it wrong, and what you ended up with as a result from this was worse off, okay? Other times, not that big a deal, okay? Now I think from my working, I went with this. Okay, so if you did it differently, why don't you follow along and see how it diverges and how it ends up being the same. Okay. Right. Now if that's you, what's du on dx?
Oh my god.
Rough game. Du on dx is equal to, if this is what I've chosen, it's just e to the x, isn't it? Okay, so I continue my way around the box. I need my dv, okay, which must be sine. Okay. So what's v? What's the primitive? What's the primitive of sine? Negative cos. Okay, let's put this thing together. This is equal to, you just read down the one column, right? So I'm going to get negative e to the x cos x. And then you go this way, right? So now I want to subtract the integral of, now I've got a double negative here, right? So I'm going to turn that into a plus e to the x cos x dx. Did I choose it wrong?
Yes. No. No.
Now, I mean, you may well conclude that I have chosen wrong, okay? However, often you will run into this problem, that no matter which way you choose, you end up with something and you're like, ugh, okay? Now the thing is though, have a look at this. This is another product, right? I can work with this. I can work with this. So I'm going to take that, maybe I'll put it off onto the side, okay? The integral of e to the x cos x with respect to x, okay? Now I can do exactly what I did before, right? Can't I break it up in this way? How would you break it up? You could do it almost identical, couldn't you? Okay? Instead of the, I'm going to go e to the x again, which means e to the x again, but I don't have sine x as my other factor. I'll have cos, so what's the primitive of cos? It's sine, regular sine. Okay? So therefore what I'm going to get here is e to the x sine x minus v du, right? Sine x e to the x dx. Now at this point, you may well wonder, have I done something wrong? I feel like I've gone in circles, okay? Because I've come back to the original integral, right? But this is okay, the universe is not exploded yet, and the reason why, believe it or not, is that minus sign. That minus sign saves the world. Watch, okay? Now, this is why it was easy to call it I, or helpful to call it I, okay? This is e to the x sine x minus whatever that integral was. Are you okay with that? Yeah. So now I'm going to take that result and stick it in here where I needed that integral, okay? So I have I equal to negative e to the x cos x plus this stuff. Minus I. Did I get my signs right? Yeah, I think so. Okay. Now, can you see why the negative is so important? You see what difference it makes? That I can move it around just like any other integral, right? So if I move it over this side, I'm going to get 2i equals this. I'll rearrange it so I have my negative in the middle. See what I've done? And now I want capital I, right? So I'm just going to divide by 2. I might as well take out this factor while I'm at it. Okay? Is that all right? Oh, constant, thank you. So there's a couple of things to note there, right? Firstly, just to help yourself, right? let the integral equal something. Secondly, do not be deterred when you see another integral. Often, you'll just have to integrate by parts again. Okay?